Good evening, ladies and gentlemen. My name is Daniel, and I'm here to introduce our project titled Corpus-based Machine Translation System with Deep Neural Networks for Kinyarwanda to English Translation. With me here are my group members, Ian, Moise, Vital. We're going to be talking about the problem overview, the tasks, the method we use to arrive at the results, and the conclusion. I'll invite my colleague, Moist, to continue from where I stopped.
Thank you very much. The problem overview of our project is that we are trying to solve the communication between people who are speaking different languages. For instance, if someone is speaking Kinyarwanda and don't know English, we can use this model to translate Kinyarwanda to English so that you can communicate with someone who is speaking English. Mainly, our project will help people to communicate between each other. The people who are coming from countries that speak different languages. For instance, the people are coming from Rwanda will be able to communicate with the one who are speaking English. So let me call upon my colleague to continue on the task and the method used.
Okay, thank you. To achieve our goal of translating, so after acquiring the data, we had to do data transformation. So the data acquired was the letters and the sentences. So we had to tokenize them so our model would understand them. Also, our data size was around 25,000, which was composed of Kinyarwanda English parallel sentence. Also, other tasks that we had to read the papers that that demonstrate how to translate from one language to another. So let's continue to the method. So the method, we had an architecture that we used. So we picked it from the paper. So here it had the three main part, which was encoder, attention, and decoder. So the input was the Kinyarwanda, here is X, and passes through encoder. So to get the embeddings that should be passed through attention, and the decoder part was there to just to transform back to English. So let me call upon my colleague to continue with the results.
Thank you. During our model, we have used two evaluation metrics. We have used accuracy and validation loss for the validation data. So for the first time, we have just used the pre-trained model, the model that are built by other people to translate one language to the other. By using this pre-trained model, we have used transformers for T5 base. We have to choose T5 base because we have our data set is very low compared to the ones they have used. And by using this model, we got validation loss of 1.32 on 20 epochs we have trained. And we have also built our own transformer model where we put some transformers there, and we got an accuracy of 0.35 on 15 epochs we have trained. This accuracy was somehow surprising because we're expecting to get good accuracy. However, depending on the time we had, we didn't get enough time to continue changing our parameters to improve the accuracy. So comparing to the result of the others that have obtained, for the reference we used on T5 model transformer we have used, for them they got 0.8 as validation loss, while for us we got 1.3. And for the building our own transformers, for the differences we had, they got an accuracy of 0.54 on their first epoch, while for us we get 0.45 on the 15th epoch. So this is like where I said we were just trying to modify the parameters we have to see if we can improve the accuracy. However, at the time was not our very good friend. And in conclusion, we have concluded that our model can have a real-world application that can impact many people, because this can help people to communicate between each other. For instance, if someone is speaking Kinyarwanda and want to communicate to an English speaker, this model can help them to translate between the languages. Thank you very much.